Bismillahirrahmanirrahim. So if you take a look at page number 16 at the top, you have the significance. Now this significance is important for 2 marks. Okay, in B, in creative ABCD 4% B, this significance, are important for those 2 mark question. At constant volume, the molar specific heat of a gas is 12.5 joule per mole per Kelvin. What does it mean? Or what is the significance of it? This is what they are going to ask you. So then you have to say that the heat energy required to raise the temperature of 1 mole by 1 Kelvin is 12.5 joule. Okay. So just one line answer, but you have to write the main thing that for 1 mole and to increase the temperature by 1 Kelvin, this is the amount of heat energy you require. Now, depending on Cp or Cv, you will write that the pressure is constant or the volume is constant. Okay. Now, the second topic that we have is Cp is always greater than Cv. Now, why is that? Let us go through. The molar specific heat at constant pressure is always greater than the molar specific heat at constant volume Cv. Let the temperature of 1 mole of a gas is to raise through 1 Kelvin. Okay, 1 mole of a gas, 1 Kelvin. Okay. So when a gas is heated, keeping its volume constant, its pressure is increased. Definitely, when you won't let the volume change, okay, it wants to expand, but you are not letting it expand. Volume you are trying to keep constant, then the pressure inside it, definitely it will go up, it will increase. Okay, in this case some amount of heat is required to raise the temperature, correct or not? So if you apply some, if you supply some amount of heat energy, what will happen? The temperature will increase. But when the gas is heated, keeping its pressure constant, then the heat is not only required to increase its temperature, but also some additional heat is required to expand, because you are trying to keep the pressure constant. This is very important to understand. Okay. See, much more amount of heat is needed when you are trying to keep the pressure constant. Why it is that? We generally consider that the gas is inside a container, right? 3-side fixed. The top part, we consider that a movable piston is there, a frictionless piston is there. So if the gas wants to expand, the friction has, the piston has to go up. So whenever you apply some heat energy, let us say you are keeping the volume constant. You are keeping the volume constant. So as a result, what will happen? We are considering Cv now because the volume is constant. So the amount of heat energy you supply will be used to raise the temperature only, no other work. Correct? But let us think about it this way. You are trying to keep the pressure constant now. Okay, so what will happen when you supply the heat? The supplied heat will be used in 2 purposes. Previously it was being used in 1 purpose only, but now it is being used in 2 purposes. The first purpose is definitely the purpose we want, that is raise the temperature by 1 Kelvin. That is our target. But another work will also go on, that is the gas is trying to expand. It will try to push the piston in the upward direction, because if you want to keep the pressure constant, you have to let it expand. When you are increasing the temperature, you don't want the pressure to change, then you have to let the gas expand. This one we already discussed. This is also according to Boyle's law, right? So now if the gas wants to expand, it has to do some work. Whenever there is change of volume, we know that it is doing some work and it is pushing the piston in the upward direction. So it will require more amount of heat to raise the temperature. Why? Because previously in case of pressure, all the amount of heat energy you were supplying, it was used just to increase the temperature, so less amount of heat was required. But now more amount of heat will be required, because the heat energy you are supplying, some of the heat energy is being wasted to expand or to push the piston in the upward direction. So in case of Cp, that is the molar gas, not gas constant, molar specific heat for constant pressure. When you are trying to keep the pressure constant, you are having to supply a little bit more amount of heat. Why? Because here the gas is doing some work. Okay, it is pushing the piston up. For that, some energy is being lost. So that energy which is being lost, it cannot be used to increase the temperature. So to increase the temperature, you have to supply some additional amount of heat, which will result in an increase of 1 Kelvin temperature. So as a result, the heat supply will always be greater in case of constant pressure. Do you understand my point?
জি স্যার বুঝছি।
ওকে, সো তাইলে এখানে মেইন যে জিনিসটা আমি যদি সামারাইজ করে তোমাদেরকে বলি, ভলিউম কনস্ট্যান্ট রাখার সময় আমরা ভলিউম কনস্ট্যান্ট রাখলে কিন্তু কোনো কাজ করি না। সো যতটুকু হিট আমি দিব টোটালটাই 1 কেলভিন ইনক্রিজ করার জন্য কাজে লেগে যাবে, অন্য কোনো দিকে হিট কোনো লস হবে না। কিন্তু যখন আমরা প্রেসার কনস্ট্যান্ট রাখবো, ভলিউমকে এক্সপ্যান্ড হইতে দিব, তখন এবার কি হবে, আমরা যতটুকু হিট দিব, মনে করো আগে তুমি 12.5 জুল হিটই দিছ, ওইটাই এনাফ ছিল 1 জুল কেলভিন সরি 1 কেলভিন টেম্পারেচার ইনক্রিজ করার জন্য। বাট এখন তুমি 12.5 জুল দিলা কোথায়, কনস্ট্যান্ট প্রেসারের সময়। তুমি যদি এটা দাও দেখবা যে টেম্পারেচার 1 কেলভিন বাড়ে না। কেন? কারণ এই 12.5 জুল যে এনার্জিটা তুমি সাপ্লাই দিছো, তার কিছু এনার্জি ভলিউমটা এক্সপ্যান্ড হতে কাজে লেগে গেছে। তো যে কারণে 1 কেলভিন ইনক্রিজ হওয়ার জন্য যতটুকু দরকার ছিল হিট, ততটুকু হিটটাও নিতে পারে না। সো অ্যাজ এ রেজাল্ট তোমাকে অ্যাডিশনাল কিছু হিট দিতে হবে। সো এই কারণে সিপির ক্ষেত্রে, সিপি এটা কি, the amount of heat required to increase the temperature by 1 kelvin of a 1 mole of a gas, right? So 1 এখানে টেম্পারেচার 1 কেলভিন ইনক্রিজ করার জন্য তোমাকে একটু বেশি হিট দিতে হচ্ছে। সো এই জন্য সিপি will always require more heat than সিভি। Okay, so this is there. Now let us go through the paragraph and let us see whether there is any line which you didn't understand. আচ্ছা, so when a gas is heated, keeping its volume constant, its pressure is increased. In this case, some amount of heat is required to raise the temperature. Yes, a certain amount of heat is there which is required to raise the temperature. Okay, this is for constant volume. But when the gas is heated, keeping its pressure constant, then heat is not only required to increase the temperature, but also some additional heat is required so that the gas can work against the external pressure. External pressure is there, but against that it has to expand, it has to push the piston in the upward direction or in the outward direction, as we say. So so the heat required to increase the temperature through 1 kelvin of 1 mole gas, keeping its pressure constant, is greater than the heat required to increase the temperature through 1 kelvin of 1 mole of a gas, keeping the volume constant. ভলিউম কনস্ট্যান্ট রাখার সময় যতটুকু হিট লাগবে তার থেকে প্রেসার কনস্ট্যান্ট রাখলে যতটুকু হিট লাগবে সেটা বেশি হবে। So the molar specific heat at constant pressure Cp is greater than the molar specific heat of a gas at constant volume, that is Cv. Okay, now the bottom part, that is change in internal energy. This is very important. The last equation, that is du is equal to cv dt, and the equation dq is equal to mcv dt. These are very important equations. Okay, we are going to use this in case of numerical problem solving. Okay, and please remind me to give you some assignment today. Okay, as we need to submit it to the ministry. Okay. Let there is m mole of gas in a cylinder fitted with frictionless piston. Here, this is the system we have been imagining since we started on discussing about all the processes. The pressure of this gas be P, volume is V, and the temperature is T. And the internal energy, as we always represent that using U. Now dq amount of heat is supplied to the gas so that internal energy changes by du. Yes, this is the first law of thermodynamics, right? And the external work done is dw. So dq will be equal to du plus dw, right or wrong? Okay, then from the first law of thermodynamics we get, oh, it is already written, so dq is equal to du plus dw. But due to the application of heat, if the volume of the gas be expanded through dv, then we know that dw is equal to pdv. Yes, this is the isobaric process. If you remember, the work done in isobaric process is what? dw is equal to pressure into change in volume. So dw we will replace in that previous equation, dq is equal to du plus pdv. Now if I want to find out, the topic that we have been studying is the change of internal energy. We want to find out what is du is equal to. So du I will keep in one side and I will change PdV to the other side. So what will happen? It will be du is equal to dq minus PdV. Okay. Now, if the volume of the gas remains constant, okay, now we are considering the isochoric process in which the volume is constant. So as a result, dV, that is the change of volume, that will be zero now because the volume is constant, it is not changing. So if dV is equal to zero, then what we know? du will be equal to dq because no work done is there. Only du and dq is there. So whatever heat I am supplying, it will be used to increase the internal energy because no work is done. If you remember the analogy that I gave you, whenever I supply you some money, you use it for two purposes. Either you save some money or you spend it. There is no other way. Okay. So if you say that, sir, I did not spend any money that you gave me, that means you have saved all of the energy, so all of the money. So using the same analogy, we can say that the heat energy I supply, you use it for either of the two purposes. You increase the internal energy using the heat energy, or you do some work. If you say that, sir, I didn't do some work, then definitely you have saved all the energy that has been supplied by me and used it to increase your internal energy. Okay. So that is why du is equal to dq. So it is observed that the increase in internal energy is equal to the amount of heat supplied to the constant volume. This is what I just said. Okay. Now we know, keeping the volume constant, if dq amount of heat is supplied to m mole of gas, then Cv is equal to dq by mdt. This is just the repetition of the equation 1.29, right? At constant volume, Cv is equal to dq by mdt. So now from here, if I want to find out the value of dq, if you remember, all I have to do is cross multiply. So I have cross multiplied here, okay? dq is equal to mcv dt. Now, if I put, if you remember, we already got dq is equal to du. Now dq is equal to, I got mcv dt, so I can write du is also equal to mcv dt because both of them are equal to each other. Okay, so du is equal to mcv dt. Now if we take 1 mole, that is the value of m is 1, then we can clearly say du is equal to cv dt only because the value of m has been replaced by 1. Now multiplied by 1, it remains the same thing. So equation number 1.30, up to this, anybody has any doubt? ইরফান, তোমাকে রোবটের মতো শোনা যাচ্ছে। Today 15 students present. 2 জন present না, এরা কারা? কারা কারা প্রেজেন্ট নাই আজকে?
সাজিদ
আর
স্যার,
ফাহিমা।
সাজিদ আর ফাহিমা।
রনি নাই স্যার।
3 জন? তোমরা কি 19 না 18 স্টুডেন্টস?
স্যার আপনাকে নিয়ে 15 রাখা স্যার।
একটু আগে না 16 দেখলাম। এই যে পার্টিসিপেন্ট 16 তো।
স্যার তার মধ্যে একজন আপনি।
হ্যাঁ সেটা তো জানি, তো তোমরা, ও আচ্ছা, রাইট সরি। তাহলে রনি, সাজিদ আর হচ্ছে ফাহিমা। ফাহিমা তো জেনারেলি ক্লাস করে নাকি না? আচ্ছা ঠিক আছে, যাই হোক, সাজিদকে আসলে একটু মেসেজটা পাস করে দিও যে জানি না ওর আসলে কি চিন্তা ভাবনা, ও যদি, ও মনে হয় বাংলাদেশে চলে যাবে নাকি না। কারণ এভাবে যদি করে, ওর তো 80% অ্যাটেন্ডেন্স হবে না, প্লাস ও অ্যাসাইনমেন্ট আসলে সাবমিট করতেছে না, তো ওকে কিসের ভিত্তিতে ওকে যে পাসিং মার্ক দিব বোঝা যাচ্ছে না। So we are going to discuss about Cp minus Cv is equal to R, how this derivation came. So as always, we will be starting from the first law of thermodynamics, that is dq is equal to du plus dw. Now, as you remember, dW is PdV. Okay. Now, what is du? A little bit ago, we saw that du is equal to Cv dt. We are considering it for 1 mole gas, right? Now, what is dq? For constant pressure, what we see, Cp is equal to dq by dt. It is generally m dt, but m we have considered for 1 mole gas now, so m is not there anymore because the value of m is 1. So dq will be equal to Cp dt. Okay. Now this value of dq and this value of du we will replace in that equation. Is it du, dw, du, and dq? These three value we will replace here now. So dq we have got Cp dt is equal to du is Cv dt. Cv dt. This is the equation 1.34, which is written a little bit, wrong in your textbook. So you may correct it. dW, it is PdV. In your book, it is written as Cp, but this is not Cp, this is going to be Cv. So again, we know that PV is equal to RT. It is basically nRT, but n is number of mole, which is 1 here, so that is why only RT. Now, if we differentiate it, okay, with respect to temperature, then what will happen? Pressure, this will come out, and it will be dV dt is equal to RO. I have to actually differentiate this side also, right? Okay, so ddt RT. Now, as you can see, this will become R is constant, so it will come out and it will become dt dt. So they will cancel each other and it will become 1 only. Then we will have P dV dt is equal to R only. Then this dt, if I cross multiply, it will become P dV is equal to R dt. So PdV is equal to RdT. Here we have PdV. So can I replace PdV by RdT? I definitely can, right?
Yes.
So this line I will rewrite as Cp dt is equal to Cv dt plus R dt. So if you take a look at my desired equation, Cp minus Cv, that means Cp and Cv, they both should be in one side, right? So I will change the side of it. Cp dt minus Cv dt should be equal to R dt. So from here, if I take dt common, then what will happen? Cp minus Cv, it is going to be into dt will be equal to R dt. From both sides, if you vanish the dt, then you get your desired equation. Cp minus Cv is equal to R. Now, if you take a look from here also, we can say that the Cp is always greater than Cv. Why? Because if Cp is greater than Cv, then only if you subtract it from one another, then you will get a positive value, right? See, Cp is greater. That is why when you subtract Cv from Cp, you get a positive value, that is the universal gas constant. We know that universal gas constant, this is a positive thing, not a negative thing, right? So that is why it also shows that, okay, this is Cp is greater. Also, we can rewrite the equation as Cp is equal to R plus Cv. So when you add something with Cv, then only you get Cp. So this also shows that Cp is greater than Cv. I hope this is clear. Anybody has any doubt?
No, sir. Clear.
Okay. Now moving to
Sir?
the next. Yes.
Okay, 8.31, right?
8 point. Huh?
R value 8.31 না
8.314 joule per mole per Kelvin.
মানে সিপি আর সিভি যতটুক যেটাই হোক ওর দুটোটা মাইনাস করলে 8.31 আসবে
Yes. Okay.
জি স্যার বুঝছি
Okay, now page number 18. The ratio of two molar specific heat, and this ratio is known as a special symbol, that is gamma. Okay, I hope you all are familiar with the symbols alpha, beta, gamma, right?
Yes.
Okay, so the ratio of two molar specific heats, one is Cp, one is Cv. So in thermodynamics, the ratio of molar specific heat at constant pressure to the molar specific heat at constant volume is very important quantity. This ratio is denoted by gamma. Okay, now this gamma value is also constant. Why this is also constant? For a particular gas, okay, it is constant. If you change the gas, then definitely it will change. But for a particular gas, it is constant because it is ratio of two constant values. So if these two values are constant, whom we are taking ratio of, then the answer will give me another constant value, right? So that is why. Oh, sorry. Acha. If you take a look at this, can anybody tell me what we can say about the value of this gamma? We can say a particular thing about this value of gamma. Can anybody tell me what is that? Kindly do not look at the book. Try to say me without looking at the
Is
book.
that one?
Huh?
One.
What is 1? The value of gamma is 1?
Yes, sir.
Okay, if the value of gamma has to be equal to 1, then Cp has to be equal to Cv. Is Cp and Cv equal? Is this what we studied till now? What we studied, Khadija? What is the relationship between Cp and Cv? Are they equal?
No.
No, they are
Sir,
not equal. Definitely Cp.
sir,
Right? Bolo?
sir, Cp is proportional to Cv. যদি gamma constant है.
No, I want to know something about the value of this gamma, not the relationship between Cp and Cv. I know what is the relationship between Cp and Cv. I know the relation. I want to know. Can you say something about the value of gamma?
পজিটিভ স্যার
Huh?
পজিটিভ হবে
Definitely
By
positive.
unitless.
If the ratio of two positive things, definitely it will be positive. But there is a special thing that I can say. Can I write gamma will always be greater than 1?
হ্যাঁ স্যার হ্যাঁ ঠিক আছে
Definitely gamma will always be greater than 1. Why? Because gamma is equal to a fraction, right? This fraction always have a greater numerator than the denominator. Since this is Cv, the denominator, the numerator is Cp. We know that Cp is always greater than Cv. So the numerator is always greater than the denominator. So the result that you are going to get, that is always going to be greater than 1. Now you might wonder that how this is possible. If you write any fraction with greater denominator and find out the answer from the calculator. See, I write 5 divided by 3. This will give me a value greater than 1. Actually, in the numerator, you write any number that is greater than 3. Any number. You write any number greater than 3 in the numerator, the fraction is going to give you a value greater than 1. Okay? It will be equal to 1 if you write 3. If it will give you a value less than 1 when you write a number which is less than 3. Okay? So as we know that here in the numerator, we are never going to get a value that is equal to the denominator, nor we are going to get a value that is less than the denominator. Always the numerator is going to be greater than the denominator, right? So as a result, the fraction will always give you a value which is greater than 1. Shouldn't you have been able to say this? Saud? ঘুমাচ্ছ না কিনা? কোনো রেসপন্ড করো না কেন?
স্যার ঘুমাচ্ছি না, দেখতেছি না।
দেখতেছো তো, তাইলে এটা তো আনসার দিতে পারার কথা ছিল তোমাদের। আচ্ছা, যাই হোক, We have 2 minute time, so let us try to finish this topic at least within this 2 minutes. Okay, so gamma is equal to Cp by Cv. Okay, now what is the unit of gamma? Can anybody tell me from here?
Sir, unitless.
Yes, it will be unitless. Alhamdulillah. So why it will be unitless? Because this is the ratio of two similar quantity, right? This is also joule per mole per Kelvin. This is also joule per mole per Kelvin. So all quantities will be cancelling each other. It is just like the efficiency. Okay, efficiency is the ratio of two energy, or we can say two power. So they cancel each other and it becomes unitless. Okay. With the help of the kinetic theory of gas, for monoatomic gases, monoatomic gas means mono means one, atom means atom. So one atom gas, it is obtained. The value it has been actually calculated practically, experimentally. Okay, so they didn't give any details about the experiment. Here they just mentioned that for monoatomic gas, we will take the value of Cv to be 3/2 R. Okay, so for monoatomic gas, Cv, it is going to be 3/2 R. Okay, fine. Now we will try to find out what will be the value of Cp. Now we know that Cp is equal to Cv plus R. Okay, so Cv already we got 3/2 R plus R. So if you do the summation, you are going to get 5/2 R. Okay, so similar type of calculation, it has been shown for, let me calculate the gamma also for you. Okay, so gamma will become now Cp, I have got 5/2 R, and Cv 3/2 R. So R and R, they will cancel each other, and 2 and 2, they will cancel each other. The answer is going to be 5/3. So if you take 5/3, it will be 1.6666, and it will continue up to infinity. So we take up to 2 decimal place and round it up to 1.67. Okay, so this is the value of, oh, yes.
সিটি স্টার্ট হয়ে গেছে
কি স্টার্ট হয়ে গেছে?
আইসিটি
Oh, ICT. Acha, okay. So, okay, I hope this is clear. So we will continue it from here in the next day. Okay, kindly go through rest of the calculation so that I can start from PV gamma equal to constant from this topic that is in the next page. Thank you very much for joining. Assalamu alaikum warahmatullahi wabarakatuh. See you in the next class.